Hello and welcome back to the series जिसका नाम है Machine Learning Mastery. Today we are going to talk about one of the most basic and most intuitive supervised machine learning algorithm. This is the first algorithm of the series under supervised machine learning. The algorithm is K nearest neighbor. So let us understand what is the supervised approach of K-nearest neighbor. K-nearest neighbor is a supervised classification learning algorithm. K-nearest neighbor is primarily used as a classification algorithm, but with a simple hack could also be used for the regression. We'll see later in the slides how that would work. What K-nearest neighbor does, it uses proximity to make classifications or predictions. By proximity, we mean the closeness or the distance. Knn could also be used for regression. Objective of Knn algorithm is to identify the nearest neighbors of a given query point in order to assign a class label to that point. So we first identify the nearest neighbors associated to a particular point of which we are looking for the label, class label, and then we try to assign the class label based on the nearest neighbor. The number of nearest neighbors depends on the value of k that we select. It is an instance-based learning or non-generalizing learning. What this means is at the training time, it simply stores the training instances. There is no computation happening during training time. All the computation happens when we make a prediction. Hope this makes sense. Let us now move forward to the next slide. Looking at the slide, what we understand is, say for example, this purple dot represents our query point. We have two classes, one on the top left, one on the bottom right. The first is class A, the other is class B. If we have to assign a label to this purple dot, what would we do? We identify its nearest neighbors. Say for example, if we have 3 as its nearest neighbors, then that would be these 3 points. However, if we want to have more points included in the nearest neighbor, so these would be its nearest neighbors. So based on the nearest neighbor, it would identify and have its own class. We'll see later what that would be. So understanding from the definitions, basic nearest neighbor classifier uses uniform weights. What this means is each of the points here within the nearest neighbor space would be assigned a weight of 1. They would have a equal voting power. However, there is another weighted KNN where the points would have a vote which would be inversely proportional to the distance of the point from the query point. Okay. Weighted nearest neighbors assigns weight inversely proportional to the distance of the point from the query point. We need to understand some of the distance metrics, which is a prerequisite to KNN. As we previously talked about, that the weights would be assigned based on the distance. The nearest neighbors would be decided based on the distance of the points from the query point. So what are these distance metrics? There could be ample of distance metrics that could be used, but just to summarize, some of the most common and most popular ones that are being used in KNN are the Euclidean, Manhattan, Minkowski, Hamming. There could be other as cosine distance, Jacquard distance, and a lot many others. What is a Euclidean distance? It is the straight line distance between 2 points in the Euclidean space or the coordinate space. You see the formula which is there as the square root of summation over points xi minus yi whole square. Manhattan distance is nothing but the taxi cab distance. What we understand, we just take sum the distance between each of the points along this available Cartesian space. It is not the straight line distance, rather it would be the distance of the total path that an object would need to take to travel from point A to point B. Okay, so its formula is as this: d is equals to summation over modulus of xi minus yi. Minkowski distance is just the generic idea behind the Euclidean distance. Euclidean distance is a special case of Minkowski, right? Even we can say Manhattan is a special case. The generalized form is denoted as this, okay? As we see as the third formula here. What is Hamming distance? Hamming distance is primarily used for comparing two binary strings. It denotes the number of bit positions in which the two strings are different. Okay. To learn more about it, you can refer to the link here, which we can see as this under kg digits. There are a lot of different distance metrics as well. Euclidean, we have cosine distance, we have the Jacquard distance. Okay, so what is Jacquard distance? So Jacquard coefficient is a similar method of a comparison to the cosine similarity due to how both methods compare. The Jacquard approach looks at two data sets and finds the incident where both values are equal to 1. Let's not go into the details of it, just understand some of the basic distance metrics that we primarily use. Okay. Now, understanding the intuition behind KNN. It is a very intuitive algorithm. If you just understand its most basic intuition, you'll have a very thorough understanding of the algorithm as well. First of all, we take the data set. Here we are taking the data set in the 2D space. We have the class labels associated. We have a yellow, green, orange, and we have this query point denoted in the light blue or grayish color. We calculate the distance of this gray point. Understand now this distance computation is taking place at prediction time when we are predicting for this particular query point. The distances are computed based on the distance metric that we decide, whether Euclidean, Manhattan, Minkowski, or whatever else. We find the nearest neighbors to these points. We associate like which are the points that are nearest to it. Or similarly, all the points would have their order of the nearness to this point. Now, based on the value of k that we decide to choose, right, we pick the most close points from this query point. Say, for example, if we choose k as 4, then we would select the 4 points that are the closest to this query point. Now, a simple Knn algorithm or the very basic Knn algorithm would work as it will simply take the majority vote. Whichever class is in majority among the nearest neighbors, that class would be assigned to the query point. So, in most logical sense, k is usually chosen to be an odd number instead of an even number to avoid any conflict of like a bal or a what we can say equal voting between the two. So to avoid that, we just take k to be the odd number. Next is we'll understand the algorithm. Just I'm going a bit fast here, but you can slow down the video and try to grasp it. But it's so simple that even in just one instance, you'll have a complete understanding of it. Algorithmically, we first specify a value of k. How do we choose the value of k? That is based on the experimentation. We make the plot, different plots, and based on the inflection, like the training versus test accuracy measures or performance measures, and we take the inflection point for our best value of k. Okay. To select the k nearest neighbors, we choose a distance measure and pick the nearest k points as we mentioned. The neighboring points are weighted. Either we choose a weight to be 1, that is uniform weighting, or we choose a weight which is inversely proportional to the distance. Majority vote decides the label for the query point. The time complexity. Now, talking of the time complexity, the training time complexity is nothing, it just stores the training instances. So it would be order of 1. However, it would take a lot more time during testing because all the computation takes place during the prediction time or the test time. At test time, the model computes the distance of the query point to all points in training. So time complexity for each query point would be order n. So if there are m query points, it would be order mn. Okay. Next up, understanding the bias variance trade-off for KNN. Since we understand that KNN is a nearest neighbor-based algorithm, understand intuitively that if I decide to just make a decision based on my one friend, so that would be a very biased decision, right? That would be a very biased decision because that one person could be wrong in most cases and there is no way to judge or assess it appropriately. However, if I decide to choose a very large number of people, right, so if I take just one person, that would be a very high variance model because even just a small conflict or small change in that individual or that nearest neighbor would lead to a greater change in the query point itself or myself, right? However, if I choose a very large value of k, the neighbors, that would be too sparse. In a sense, it would not be able to make a true picture of the individual. It would be much more generalized than necessary or than is required. Okay, so lower value of k leads to a high variance model, whereas higher values leads to a less variance model. It is non-parametric, which means it does not make any assumptions about the data distribution. Therefore, it is a low bias model. This is very important to understand. We talked about bias variance. Now we'll talk about algorithmically which algorithms in a basic sense are a high variance or a low variance or a low bias or what else could be. Now, making the intuitive hack behind KNN regression. Nearest neighbor approach could be applied to cases where the outcome are continuous values rather than discrete. Okay, that makes sense because in regression we have continuous values. The value assigned to each query point is computed based on the mean values. Here I'm talking of mean, but that could be any aggregate. You could take the median, you could take some other value, mathematical computation of mathematical average, weighted average of those values. So it's just the computation, mathematical computation at the end based on the nearest neighbor, the values assigned to the nearest neighbors. Okay. Here is just a simple diagram to understand like how the k and neighbors regression works, like a high variance or low variance model. If you choose the value of k with weights that's uniform, what is the I prediction line? And if you choose the weights as based on distance inversely proportional to the distance, what is the prediction line? Okay, so just the algorithmic part of it and what it makes. So hope you enjoyed the lecture. Hope you learned something new, and it is very intuitive. Go back to the lecture if you feel, if you find something which is not clear in the first instant. I'm sure that would be absolutely clear to you. Just also at the same time, if you want to reach out to me and have any queries, feel free to drop a comment or reach out to me on LinkedIn. Thank you very much. See you in the next lecture. Bye bye.